All right, everybody, here are 3 examples of how we're going to use logarithms to solve an exponential equation. You can see each one gets a little bit more complex than the one prior to it. But we're going to build on the idea that if we are solving an exponential equation, meaning that x is part of the exponent, then we need to use logarithms because they are the inverses of exponents. Right? So the first example is very basic, and I want to demonstrate that there are 2 main components here. On the left-hand side, you have your base, which is 10, and you have your exponent, right? Your base and your exponent. Once you get the left-hand side that only have a base and exponent, then you are set to go ahead and use logarithms to solve it. So I'm going to log the left side and log the right side. Whatever you do on the left, you have to do on the right. And as we stated, base 10 and log are inverses of each other. So now the left side just says 3x equals log of 4. Okay, the goal is to solve for x, so we need to divide by 3 on both sides. And this is our final answer. X is the log of 4 divided by 3. I want to point something out very important. This is not the log of 4/3. This is the log of 4, that whole quantity, divided by 3. I'm perfectly okay with you leaving it like that because that's an exact answer. If you actually calculated this with a calculator, you get some crazy decimal, and this is actually more precise. So I'm perfectly fine. But if you're leaving it this way, but if you're curious about what that is numerically, go for it and you can calculate it and see what it is. All right, so now we look at the next example. We see we still have a base and an exponent, but our exponent's a little bit more involved. 3x minus 7, that whole quantity is our exponent. But since on the left-hand side we just have a base and the exponent, we can start right away by just logging both sides. And the log and the base 10 are inverses, so that just cancels out. And you get 3x minus 7 is equal to log of 4. Okay, so now we wanted to solve for x. It looks more or less like a linear equation at this point, right? So to get x by itself, first we could add 7. That's a 7. And we're going to get 3x equals the log of 4 plus 7. That does not become the log of 11. It's the log of 4, that's a number, plus 7. So that's a completely different number. We cannot combine them. Right, and then we need to divide by 3 to get our answer. Divide by 3. And we just leave it like this. The log of 4 add 7. Divide that whole quantity by 3. Perfectly fine with you leaving it in that form. Okay, it's a very precise answer. All right, now let's look. We're going to jump up quite a few notches here, the next one. Right, on the left-hand side of our equation, we got lots of things going on. We got our base, we got our exponent, but then we also have these 2 other numbers, the 6 and the minus 7. We cannot use logs until all we have on the left-hand side is the base and the exponent. So we need to get rid of the 6 and this minus 7. So we're going to get rid of the minus 7 first. We're going to add 7 to both sides. Okay, 6 10 to the 3x power equals 11. Again, I can't use a log until I get rid of the 6. I need to have just the base and the exponent. So we need to get rid of the 6. This is 6 times 10 to the 3x power. So since it's being multiplied, we'll divide by 6. Okay, so now I get 10 to the 3x power equals 11/6. Right, 11/6 is a crappy decimal, guys. It's terrible. It's a terrible decimal. I'm not going to divide 11 by 6 and put a terrible decimal there. I'd rather just leave it as 11/6. Even though it's improper, I have no problem with that. Just leave it as 11/6. If it had been like 12/6, I would have changed it to 2, but it's 11/6, which is yucky. Just leave it in fraction form. So now we're okay. You can go ahead and log both sides, because we got rid of everything but the base and the exponent. And now we can cancel out the 10 with the log. Right, so now we have 10. Oh, now we have, I take that back. I have it right to make a mistake. The 10 and the log cancel each other out, and I just get 3x equals the log of 11/6. I'm going to put it in parentheses since it's a fraction. I don't want to make it clear that I'm taking the log of that whole fraction. Right now, last step is divide by 3. Divide by 3. Right, I know it's not a pleasant looking answer, but it is a very precise answer. Right, so if you need to watch this multiple times, or if you want to copy any of these into your notes, that would probably be a great idea because we're going to be using logs to solve exponentials quite a bit.